Hi, my name is Matt Holliday and welcome back to my class on programming in Go. So now I'm going to talk about how we build Go software, right? In most of this stuff, what we've done is use like Go run or Go test. Now we're going to talk about Go build, and we're going to talk about some other things around that, like building pure Go programs and putting Go programs in containers. I'm going to talk a little bit about it, and then I'm going to give you a complete demo. Okay, so as I just said, we've been using Go run and Go test. There's a couple other commands. Go build is actually going to build the software and produce a binary, a separate binary that you can just move somewhere or run. If you use Go install, it's similar, but it puts it in your Go path/bin, and if you do a Go get to get like a CLI tool, it's going to do that. But for this, we're going to talk about Go build and variations on it, okay? Now, it has various options, and I'm not going to go into all the options. The one I want to talk about is how do you build a pure Go program? And by that I mean a program that has no dependencies of any kind outside of what's in the binary after it's assembled. Okay, so in this case, what I mean are runtime dependencies. If I just go and build a Go program, it will statically link the Go code, but it might still have a dependency on standard libraries on your laptop or on some other container. Okay, libc in particular. Okay, and that's the sort of thing when you build a program in the C language or something else. If you run Java, the JVM, it has to have a libc. But the goal here is actually to be able to do something interesting, which is to provide a Go binary that is completely contained in itself. It doesn't need anything. Okay, because the interesting thing then is we can put that into an empty Docker container. A container that doesn't have a libc or other parts of the operating system, doesn't have any runtime dependencies. Well, that does two things. One, the container becomes very small. Okay, I remember taking a Java project to Go, and the Java container, when you put together a JVM and an operating system and so on, was about a gigabyte. Now, it might have been possible to constrain that. With some clever work, it might have been possible to put less operating stuff in it, right? But that's like just a CentOS image with a JVM and some Java software, some jars. And the equivalent Go program was 20, 30 megabytes because you don't need any of that other stuff. All you need is your Go binary. And it's a security issue also because you've just eliminated all these other possible security vulnerabilities. If I put a pure Go program in an empty container, a from-scratch container, right, I have a program which probably opens one port, and that's my total vulnerability. All right, so how do we do that? Now, there's one little dirty secret, and that is that exactly what these arguments are have changed a little bit. Maybe they'll change again. There's an issue to try to create a single flag static, right? And if you could pass that single flag static to Go build, it would just do the right thing. Well, unfortunately, that doesn't exist yet. Okay, so to build a static executable that's completely statically linked, you got to do a few things, right? So here are some of these things. We've got to do things like these tags of netgo and usergo, right? Because that tells the standard Go library to use its own Go versions of a couple things and not to use the ones that come out of libc. And at this point, I don't think it really matters. I certainly have not run into any problem using the Go variants instead of using the variants that are built into the operating system. I mean, not the operating system, but in the library that you get in an OS distribution. Okay, we've got to tell the linker, right, to link it statically. And these arguments tell it to link it statically, strip it, and so on, so that there's nothing extra in it. Okay, and if we do that, we're going to get a program that is not going to be a dynamic executable, right? If I do this on Linux, I'm going to get a binary that is completely static. You hit it with LDD and it says not a dynamic executable. So it has no runtime dependencies on dynamic libraries. Now, dynamic libraries were a neat idea when they were new. They may have come out in the 70s. They were certainly hot in the 80s. There was a period when Unix was new, when most machines were small and they were very memory constrained. Go back and realize that, in the late 70s, early 80s, a lot of these machines had a megabyte or less, and certainly 4 megabytes or less of main memory. Okay, And most people built Unix software by getting the source and building it on their machine locally. They didn't get binary distributions and pick up binary packages like we do now with these various tools, okay, apt-get and so on, right? And what we got to by the end of the 90s was dynamic library hell. And so we don't want to do that anymore, right? So having this thing that's not dynamic at all is very good, I think. Now, I can't do that on my laptop. I've tried building a statically linked binary on my Mac laptop for the Mac, and I'm not sure I can do that. And that probably has to do with Apple and their security and their libraries, okay? But I can cross-build from Mac to anything else, okay? In fact, let's talk about that, right? There are several variables you can set about the platform you're building for. So the Go build tool is a cross-compiler right out of the box. I can go on my Mac laptop and build an executable for Linux on x86 or for the Raspberry Pi using ARM, for example. Okay, and there's some other targets out there. I mean, I think Go runs on, IBM mainframes. Okay, not going there. Okay, but, we can tell it what architecture to build for. And so I can go to my laptop, again, my Mac laptop, which is currently an x86, okay, and I can tell it to build this thing for the Raspberry Pi. The one I've got here is for a 32-bit Raspberry Pi, like a 3+. Okay, if I want to build for a 4 and use 64-bit, I can do that. I just change a couple of these flags in here, and I can build a binary for the Raspberry Pi. And I can literally just copy that binary by itself onto my Raspberry Pi and run it. Okay, I don't know if I'm going to do that in this presentation, but I could. I could build something this way, do an SCP, SSH into my Raspberry Pi, and run that executable. Okay, or I'm going to focus on some other things today and let you just believe that I did that and I can do it. So I want to talk for a second about project layout. Where do you put stuff in your repo? All right, and we're going to assume for this discussion, let me get to the pen again, that root is the top level of your repo. You're going to have things like a README and a Makefile. Talk about those in a second. Now, on the left here, I've sort of divided this into the things you're almost certainly going to have and the things you may have, right? Typically you're going to build a library and an executable command, for example, right? So we use the command subdirectory and directories under that for the actual main programs. And if you look back at one of my examples when we did the profiling, I had command slash, to do and command slash sort, I think, all right, under my main directory. Each one had a main program, right? Of course, you're going to have your go mod and go sum. That's part of your build process. We'll talk about that. And then you may have libraries of your own. So there's three thoughts here, okay? If you only have a couple of files, then just put them there. There's no reason to put them under directories. If you have one or two packages, then just put those package directories at the top level. And if you've got a whole lot of packages, then maybe it's worth creating the package directory and putting the packages themselves under that. Well, then I would have package slash XYZ, package slash ABC, right? Now, the thing we want to avoid though, all right, I know a lot of people who've worked in Java, and you get these things in the repo where it's com slash company slash something else slash source slash main slash Java slash whatever, I don't know, right? You got to drill down through 3 or 4 mostly empty directories to get to any actual source files. And that can be a pain. So the goal here is to have the least directory structure necessary. Let me say that again. The least directory structure necessary. There we go. Okay? So if you have a bunch of packages, then don't flood your main directory, your root directory of the repo with lots and lots and lots of directories, subdirectories. Put them under package. If you have 1 or 2, put them by themselves directly in your repo. And if you just have a few source files, like you just only have 1 package, well then just put the .go source files of your package at the top level of your repo, as long as it's not too many files, right? So we want to trade off against having a really deeply nested file hierarchy versus having a top-level directory that has way too much stuff in it to make it cumbersome. Both of those are a problem. Try to find some happy middle. Okay? If you have integration tests that need to be separate, you may put them in a test directory. Right? I've done that once or twice. Most of the time, your test files, it's x_test and it goes together with x in package x or something, right? So most of your test files, your unit test stuff, is going to be in the same directory with the packages, right? If your main program needs a test program, a test driver with it, you can put that with the main program under command. I've done that, okay? Now, on the right-hand side are things you may need depending on what kinds of things you're building, right? And I typically use short names. So build for the place to put Docker files. Deploy for the place to put Kubernetes files like deployment.yaml, right? I may have a script subdirectory if I need a place to put other scripts that are part of the build process or part of testing or something, right? And if you're vendoring, well, then you'll have a vendor directory at the top level of your repo. I should say a vendor subdirectory. And that will have all the other stuff in it, which hopefully you'll never actually look at, but it will get committed when you commit your repo. Okay? You may have other directories, right? You may find a need for a test data directory separate from the test directory. Don't know. Okay? But this is the basic layout. Now, we're going to talk about a couple of these things. All right? I'm going to get on my soapbox for a moment and say, again, I think one of the number one sources of technical debt in most of the software I've looked at is a lack of documentation, right? It sucks when you go to some new project and you need to onboard on the new project. Well, and they say, well, here's the repo, and you go look at the repo and the README has got 3 lines in it. It doesn't tell you anything, okay? Your repo README, particularly for a project where you're going to hire people to work on it, should have a lot of information. Or if you're providing a third-party module to other people, it should have a lot of information. This is sort of an outline of things you should think about talking about, right? Why does this thing exist? How do you use it? What do you use it for? Who's it for? Are there things you need to do as a developer to get ready to work in it, right? How do you get it and build it and test it and run it? And if you're running it, what are these metrics and logs and things you might need to look at? Does it need a database? What kind of database schema does it need? Folks, people say just go read the source code, and I'm going to tell you, based on 45 years of programming experience, that's not enough. And 30 years of professional development experience watching projects without enough documentation waste time. Write the bloody documentation, please. Okay. Now, Makefiles. Why do we need a Makefile? And some people will say, hey, you just do go build and you don't need anything else. And I'm going to tell you, well, in real projects, a Makefile can still be useful. And the nice thing about it with Go is the Makefile can be very short. It's not like a C project where you got to tell how to build every bloody library and all the source files, okay? But we may want to provide parameters to the Go build function like I just showed. And do you really want to type that out every time, okay? And I'm going to show you a couple things about Go build that, it really is better just to package it in a Makefile. Okay? One of those has to do with versioning the binary, the executable. All right? This is another pet peeve of mine. In software engineering, everything that can be versioned should be versioned. And one of the things is, so there's something running out in the cloud somewhere. Maybe there's just one pod in a Kubernetes deployment. Well, what's in it? Okay? I want to know what version it is, and ideally, I'd like to tie that version number back to a git commit. That way, if it's not working, I know exactly where to start looking. Is this a known bug? Is this a known bug that was supposed to have been fixed? Is this a new bug? Where should I start looking if it's a new bug for why is it there? Well, obviously the change that was committed, or the one or two before that. Okay? Now, there's a neat way to do this in Go because the build system for Go allows you to set a global variable's value from the build command line. Okay? So what we need is a variable, and I typically put it in main.go with the main function. Right? I call it version. It needs to be empty, not set to some other value. And what will happen is when we build the program, we will tell Go build how to fill that value with something. Right? And what we're going to do is we're going to tell it to fill it with something from Git. So I typically run a git command that I've shown here, and I'm not going to read the whole thing out, okay, which goes and gets a string in a certain format. And I provided a couple examples here. And this is a common way to do it. This is not my invention. I've seen a lot of people do the same thing in their projects to generate the same kind of string. The tag number, and maybe there's a number in between that counts up how many commits since the tag, because the commit may not have actually been tagged again by itself. And then the actual hash of the commit, the first 7 characters, right? The little g there, all right, just says it's git. And the 7 characters after that are the first 7 characters of the commit hash, which is usually enough to figure out, okay, what is this, right? And the way we put that into the program is, again, one of these LD flags. It's a linker flag option that basically says, as you're producing the final binary, shove this version number, and here it's an environment variable that I've set in, for example, my Makefile, shove that into main.version, okay? Now, some people will also talk about putting a build timestamp in your executable. And I'm going to say, I don't think you should do that. The ideal build process is one that is completely reproducible. Okay? If I have the same source, if I have the same version of Go, I should be able to get exactly the same binary, literally down to a secure hash, okay, in the ideal world. If I put the build timestamp in there, every binary is going to have a different hash, even if it was built from the same source code and the same tools. And yes, if you want reproducible builds, you need to find a way to control the tools, right? If you need to produce a build that was done a while ago with Go 114, make sure you still have access to Go 114 of the correct version to build that binary if you want to make it exactly the same. So what we're going to do now, and I'm going to show a couple slides and then we're going to do it, is we're going to combine these things about the versioning and the Makefile and Docker. Okay, you're going to get a quick introduction to building in Docker. I will assume you already have Docker installed. I'm not going to go through that. So on your Mac or Linux or whatever, you have a Docker and you can get to the command and run it. Right. So Docker is kind of neat because we can basically take our program and maybe some files it needs, put it into a container that's completely self-contained. And in terms compared to how we used to deploy things on Linux boxes, in the cloud, for example, or even on server racks in your office building, this is a huge improvement, right? We don't need to worry about incompatible dynamic library versions, or what configuration files are present or not present or whatever. Okay, so we get a lot of convenience and we get a lot of security. Now we can build a simple Docker file that just goes and gets the Go stuff and builds, right? But then you end up with a Docker container that still has the operating system and the Go build tools in it. So I'm going to show you what is a good practice. It's called a multi-stage Docker build. We're going to use one Docker container to build the software. And then we're going to copy the pieces we need into a second Docker container that'll be the actual thing we end up with. And it'll have nothing in it but our Go program and a couple of things like certificate files that we would have to use the network. Right? So, and this is a very neat technique for CI/CD. We don't have to worry about what CI/CD machine are we running on and what tools does it have, right? Because we'll pick our Go build container for a particular operating system and a particular release of Go and just use it, right? So this is one half of a Dockerfile. Okay, I'm going to show it in 2 parts because it's got 2 stages. This first stage is the actual build process. It starts by using a Golang container, a container that has the Go tool chain, and it's based on Alpine, and I've said, hey, I want it to be some version of 1.15. Presumably, I'll get the latest. So if we're at 1.15.7 or 8 today, that's what I'm going to get. I can't remember. I think it's Saturday, but I'm not sure. All right? Now, there's a couple things we got to do. There's some boilerplate here. We got to pull over like the certificates and time zone database. Okay, and make sure that we have those things up to date, right? Now, the next thing we're going to do on here, we're going to add a user, okay? Because we do not want to run as root unless there's some reason to, and there generally is no reason to run as root. So we'll add a user specific to our app, and we'll pick a work directory to work in, right? And then we copy, right? So this is the important step is whatever we need to build the program, including go.mod and go.sum, will get copied into our container right here. Okay, so for this case and the example I'm going to do, which is the sort animation, it's a version of the sort animation program that I showed in the section on profiling. Okay, I'm going to put that in a container. I'm going to publish my container so that you can play with it, right? So I'm going to copy into here the things that make up that program, and we'll look at that in a second, okay? I'm going to define an argument that I can pass in from the outside that will be the version that will bake into the executable, all right? And then finally, I have the actual command to do the build, okay? And notice here my version is going to be the version that I pass in, and we'll see that in just a second, right? So I'll run this Dockerfile and say, hey, for the version, use this value, and that value will be used to build the actual executable, and it'll get baked into the executable. Great. So that's the build side. When this is done, I have a container with my program. But again, that container has Alpine. My container has all the Golang toolchain. Don't need them. So I'm going to then start a new container. There's a second, and this is the same file. This is all in one file, right? There's a new from directory. Now, I could say from scratch, and I've done that. Now, there's a package called BusyBox, and BusyBox is sort of like a Swiss Army knife. It provides you some basic Unix tools in a small, statically linked package, okay? So it's still, you know, it's not as good as having a container with nothing but your binary, but it's better than having, you know, your binary and a lot of operating system executables and glibc, right? So it's handy if you actually want to, you know, if I'm building something that I'm going to put, say, in a pod in Kubernetes, and I want to be able to do top, right? Or for any other reason, I need to be able to get into it and look around, and I need a few of the basic command line tools that Unix provides. I'm going to get them out of BusyBox, okay? So I'm going to build from BusyBox, and now we're going to copy. Well, I'm going to copy the certificates, the time zone data, the password file because I created my new user to run the program, and I'm going to copy very specifically my binary. And that's the whole program right there, folks. When I copy this sort binary, that's my whole program, right? I'm going to say what user to run it as. That's the user I added. Where to run it, the home directory. The port that I'm going to expose, right? And then I just have this entry point thing that says, you know, start my binary. Now, if I needed to, I could add additional parameters, right? I could put more parameters in there. And I could also, there are ways to pass set environment variables, or I could pass in some other argument and have that argument reflected in that entry point command. So there's ways to pass a bit more stuff into here, right? Now, I'm not going to get into what a 12-factor app is. That's beyond what I can discuss in this module, okay? But the desire is for the stuff we run in the cloud, for the most part, we configure it through environment variables. And when we get to something like Kubernetes, right, well, that's part of what the deployment YAML is all about, right? Defining the environment variables, getting secrets out of the places we need to get the secrets, and providing them into the program that way, okay? And not copying a bunch of config files into the container image, okay? In fact, anything that has to do with security, right, we don't want it in your repo, and we don't want it in the container, because the container may be public or at least visible to a lot of people, right? And if there's an insider attack, even if you've got a privately built container in a private repo, well, that repo still belongs to some other company. And if there's an insider attack where they start digging through the repo, the containers looking for secrets, okay, you don't want to put them there. Right. So this line here is the end of the actual Docker file, and below that are the commands that I would use to build the Docker file, tag it, and push it to a repo. Okay, so we're going to go and do that now. I'm going to switch to the laptop. Right, so I'm in my laptop. The first thing we'll look at is the main program that I'm going to use for this sort thing, right? And like I say, it's got this global variable, and I tend to put comments like this around it just so everybody else knows why it's there and why it's not initialized. Okay, and then I have my main program, and my main program sets up the routes and so on. Not terribly exciting. You know, and I'll tell this repo is going to be like mat4biz/go class build. Or if you just go look at my repos, you can find it. It's all there. So I'm not going to go through all of the code, right? We'll just look at the main file, right? And there's a go.mod. It's not very exciting. All right. My repo has, and it may not be very visible over here on the left-hand side, right? I've got my go.mod, go.sum. All right. I've got my command subdirectory over here. I've got my build subdirectory with the Dockerfile. And then I've actually got like one program that does the basic routines of sorting animations. Okay. So that's my library. And since it's just one Go file, I just put it at the top level by itself. It doesn't need to be in a directory. Okay. It's the package that's the same as the module name of my, go.mod file, right? Okay. So what else do I have? Well, right, let's take a look at the Makefile. So the Makefile, if I need to look at sources, I've got a way of saying, hey, find all the .go files, at the top level or one level down or something. And you could change this to whatever you need it to be, right? I've got my magic command that calculates the git tag, right? This thing that has the tag and the commit hash. Okay, that's the command that does that. Now, there is one thing. If you're going to run this command, you have to have put at least one tag in your repo. So if you start with a new repo and you do your first build and you haven't tagged anything for release, then it's going to produce an empty string. Okay, you need to have tagged at least once. So I've got a little piece of code here that says, well, if it ends up empty, we'll just call it unknown. Right? All right. I've got my default make target, which is just make sort. Okay, and it'll make basically on my local machine a binary with the version. We'll show that. All right, I've got a command in here, for example, I can do make lint. It'll run the linting tool. All right. I have a very interesting command. I'm kind of showing it. I don't really need it that much in this project. I'll just show it. It's one of my pride and joy things. Okay, just in case you need to build something out of your repo on your laptop, okay, you shouldn't be publishing a container unless you've committed the code somehow, right? If your repo is dirty, you have modified files you haven't checked in, then this committed target will produce an error message, all right, if you're not clean, if your repo is not clean. Now, ideally, you're never building anything out of your laptop, right? You're committing the code into GitHub or some other repo, and you're running some sort of CI/CD process, and that process actually produces your Docker container and or deploys it to the cloud, right? You should probably not be doing that off your laptop, but if you are, you should definitely make sure you've at least committed the stuff to the repo. Because if you build out of a dirty repo, no one will ever know what was in your binary. It's not a reproducible build in any sense of the word. All right, so if I want to actually make the Docker container, right, well, that depends on the sources in the Dockerfile, right? And here's that command that will do it, right? Docker build, right? We're going to call this container sort-anim, okay? Using the build/Dockerfile as the way to do it. And we're going to pass in with this build arg. This is where the version gets passed in to set the argument inside the Dockerfile that will be used to write the software. Great. And then publish down here, right, says, oh, well, you have to have linted and you have to be committed, and we'll make the Docker container, we'll tag it. Okay, so here's another thing, right? This git version tag thing that I like to put in my binary, I like to put it on the containers. All right? And if it's in my binary, I like to make it available, say, through a route, an API route. Could be the health check, right? And you can even imagine, and I've done this, where you have an app where, the iPhone part says, I'm version such and such when it talks to the server, and the server responds and says, I'm version such and such. Because it just makes debugging so much easier, right? So I'm going to tag and push this thing when I put it up to, Docker Hub with a tag that actually matches this Git container thing. Right, so that's the Makefile, and the Dockerfile we've already looked at. This is exactly what was on the slides, right? We're going to update the certificates and time zone database, add the user, copy the source, build it, start a new container with BusyBox only, copy what we need, and set it up to run. Okay, that's it right there. So now I'm going to go over to the command line, and let's just do make sort. Actually, if I just do make, that's going to do make sort, because sort was my default. And you can see right there, okay, it's building this version, And I haven't updated anything since I checked it out. So it's not dirty, it's clean, right? And I get this tag. I have set up the way this command works. Also, right, if we go look at this command, I have this dirty option down here. Okay, if your repo is dirty, it will append -dirty to your tag. So you'll also see it. Okay, still not enough to make your build reproducible. Anyway, okay, so I've just built it. I can now run this thing. And I need to be, because I called it sort, I need to say ./sort, or it's going to try to run the Unix sort program. That's not what I want. Okay, I'm going to run it. And the way I wrote the code is the first thing it does is it logs its version and says what port number it's listening to. Right? So now I can go over to a web browser, right, and do my localhost and run my sort animation. And if you didn't see my section on profiling, you'll say, hey, this is neat. Go back and watch my section on profiling. We'll do a bit more with it. Okay, so that ran, and it produced this log saying somebody ran insert. Fine. Okay, so that was the local build. I built it on my laptop to run on my laptop. Okay. Now I'm going to do make Docker. And that's going to do a bit more. Okay, it's going to go and get the Docker file. It's going to download stuff that it needs to download onto this laptop, which it's downloading because I actually haven't done this on this laptop. Okay, so we had a pause while it downloaded stuff, and now we can see that it's actually building, and it's finished building. Okay, so it copied the stuff it needed to copy. If we go back and look at this, right, it was downloading stuff, right, and it ran various commands, finally ran the build command, and we end up with this, local container right here, sort anim. And I can run that, right? So I would run docker run. Now, the program in the container, I set it up to run on port 8081. If I don't tell Docker anything, it's going to put it on a random port. And so what I'm going to do now is I'm going to actually map the ports so that the port on my local machine will be 8081, mapped to the port inside the container, which is 8081. Okay, so it's the my port and the container port in that order. Okay, and I don't need to give it a tag or anything. I'm just going to run the container I've got right here. That should be enough to get it going. Oh, it would help if I typed the program name the way I actually built it. I don't know what happens. It's just, difficult in front of the camera. All right, so here it is. This program has started up with a log the same way it did when I ran it from the command line, except now it's actually inside of a container, right? So I can now come over here, and if I do this, I'm now running the containerized version, okay? And I'll go back here, and I see that it produced a log. Okay? I'm getting, the way I ran Docker, it's just running this way and producing these logs directly to the console, but it's from the executable that's inside the Docker container. Great. Well, let's go a step further than this, right? So we're done with this, right? I'm going to finish the job and run make publish. That's going to put a tag on this thing, and I'm going to want to copy that here in a sec, push it up to my Docker Hub account. Okay. And there we go. We see it actually uploading stuff now, right? I think it'll be faster than the download, particularly since I've got very little to push. My container's not very large at all. Okay, there it is. It's been uploaded. So what we're going to do now is I'm going to go into my Ubuntu image that I'm running in VirtualBox right here. And I'm going to do it twice. So I'm going to be logged in 2 places. All right, and I've already made sure I have Docker. Now, I need to map the ports differently because I've set up my VirtualBox so that 8888 on my Mac maps to 8080, all right, and I need to map that to the 8081 in the container. Now, I'm going to put on the version tag. So here I'm saying, hey, run the sort animation container from my public Docker Hub account, mapping its internal 8081 to 8080 inside Ubuntu. Okay. It has to go out and get it. There we go. And there it is. Now, this is inside Ubuntu running on port 8081, right? That's what it thinks it's doing inside the container. Now, on Ubuntu, I'm going to curl localhost. If I do 8081, it's going to say it didn't connect, right? If I say 8080, there we are, I get a result, okay? So my container was running with 8081. In Ubuntu, I mapped that to 8080. And the reason I did that is so that I could go over here and change this port number now from 8081 to 8888, because that's what I have 8080 in VirtualBox, or the VirtualBox Ubuntu, mapped to on my laptop. And now when I run it and go back, I'm going to see up here that, again, my Docker container, we're now running inside Ubuntu, right, just produced this log, right? So I'm going from 8888 to 8880 in Ubuntu to 8881 inside the container, right, by just port mapping, and everything else just works, okay? And you might not need to do all that much work. The reason, again, is I already had the port mapping set up for VirtualBox. Great, so there we are, right? I built my container, I published it to my public repo, and then I went into an Ubuntu image running in VirtualBox, actually got and ran that Docker container that I just built, okay? And now I'm running it, okay? Now, when I built it, okay, why is it just working in Ubuntu? Because I built it inside a Docker container based on Linux. And so it already, without cross-compiling, it just built for Linux because that's what the environment it was in, right? I could have used a container to build on Linux for, you know, my Raspberry Pi, but then I would have needed to have specified, hey, build this thing for the ARM chip and not the x86 chip, right? All right, so the last piece of this would be to go and reload my Docker Hub account and go look at this thing, mathall2/sortanim, okay, and it was just updated right here. So 4 minutes ago, I have this new tag. It's still v100-2 because it's 2 commits past the tag, right? If I go look at this thing in the history, right, I have my v100 tag and I have 2 more commits, and that's why it looks that way. And this is my thing here, which shows, and it's very, very small, but when I ran the container locally on my Mac, right, it actually showed that that container was running. Now it says exited, okay? It's not running anymore. I ran it and exited it, but here it is, right? The Docker on my Mac has that container in it. So that's my little spiel about how to build and distribute Go apps, right? Well, we talked a little bit about what is a package layout, how do we run the build tool, particularly how do we build a pure Go executable. Now, if you need to use CGO because you need to have C libraries for something that you just can't do in Go, that's not going to work. But for an awful lot of basic cloud stuff, you're going to be fine building a pure Go executable and putting it in a Docker container. And I showed you an example of doing that.